Hello everyone, and welcome to today's webinar that is an introduction to motors and drives. My name is Alessandro Ciampechini. I'm a chartered engineer, member of SIPSI, and hopefully today you will get some insight on how to save some energy on electric motors. So let's get started. Okay. This is the agenda of today's webinar. We are going to run through just a brief overview of the technology of electric motors. Then I'm running through opportunities to save energy on electric motors with focus on obviously variable speed drives and motor efficiency. And also I will give you some insight on how to set a motor management policy. And then we'll run through some of our schemes, including the Green Business Fund. Just before starting, really, what is the Carbon Trust? We are a not-for-profit organization with a mission to accelerate to move to a sustainable low-carbon economy. We are independent experts, and we operate through three different areas, three different sectors. So we provide advice to businesses, governments, and public sector on their opportunities to save energy, and obviously being in a low-carbon world, we measure and certify the environmental footprint of organization, products, and services, and also we help develop low-carbon technologies and solutions. The object, obviously, scopes of the webinar is to, as I said before, become more familiar with the technology and then give you some easy win tips to save energy, but also give you an understanding of the motor management policy and become aware of the life cost, the whole life cost of the electric motors and inverters, and obviously how to benefit from the Green Business Fund, and also to give you a methodology really to assess the condition and the energy performance of your systems and your motors within your organization. This is just to start, these are very shocking figures. Worldwide, really, 40% of the electricity is consumed is by electric motors. So this is quite a shocking data. And if we go and if we focus on the UK industry, we can see that 66% of the entire industrial electricity consumption is due to electric motors. You can find electric motors, as you know, almost everywhere within a site, especially on the manufacturing side, from heating, cooling, ventilation, compressed air, presses, and any other sort of industrial process. Just to start, this is just an overview of the motors, and obviously an electric motor converts electrical energy into rotating mechanical energy to drive devices such as pumps, fans, or conveyors. The mechanical output power delivered by a motor is measured in kilowatts and is function of the speed and the torque. Electric motors are available in standardized sizes and power ratings, usually ranging from 100 watts to several megawatts. The most common used motor are AC motors. They just use conventional alternating electric current to produce a force, a torque on its rotor, and obviously causing it to rotate. The other main area of motors are the DC motors that use direct current to produce mechanical power. The figure that you can see on the typical motor template, you can see a picture just on the slide that gives you the most important and most relevant data from a motor, from the voltage to the power to the nominal speed, the IP protection, and obviously very important is to see the efficiency class of a motor. In this case is an IE1, and obviously you can find many other information like the rated amps, the power factor, and the main supply frequency. So this template can be seen almost in all the motors that you can see at your site. Just an overview again of the what's a variable speed drive is. Variable speed drive converts the incoming supply, electricity supply, a fixed frequency into a variable frequency and variable voltage. Typically, this ranges the speed can vary from 0 to nearly 120% of its full rated speed, and up to 150% of the rated torque. Obviously, a variable speed drive is important and is useful when you require a variable speed and torque. Obviously, motors have losses, and if you see the picture on the slide, you can see that there are different types of losses. Most of them are due to heating, magnetic losses, friction, and obviously energy absorbed of the final use. In this case, it's just it's a fun, really, where you can see that there are some losses from within the drive, within the motor itself, through heating, as I said before. Obviously, there are transmission losses, and obviously even the drive itself can lose some energy during the normal operating of it. So now, once we have identified the motors and which motor we have on site, we can start looking for energy savings, really. I'm going now to run through a few different opportunities that can be assessed to save energy. Some of them are just policies. So if we start from the switch-off policy, that always is the easiest way to save energy. So obviously motors are commonly and often hidden within machinery, so they tend to be ignored and left running even when they are doing no useful work. What happens, for example, when you shut down your production for lunchtime or dinner time, or really when there's no people within a room, so your ventilation system can be still running even though the office or whatever environment is unoccupied. So the easiest way to save energy is just to switch off the motor when you don't need the motor itself. Obviously, to switch off a motor, and once you have identified which motor can be switched off, you need to consider how it could be safely switched off, and obviously you need to take into account any potential health and safety risk to personnel. So you might need to write off a policy and instruction for the operator if we're talking about a manufacturing environment. Another type of energy reduction could be to minimize the demand and optimize your process. So there are load sensing devices like sensors in tank filling applications, or timers, or CO2 sensors that can be used within building ventilation. So, for example, you can use those sensors to drive your motor through an inverter. So when no people need to use a motor, just the sensor communicate to the motor that it can be switched off. Or just a timer really can manage the motor operating hours, and obviously you can achieve energy savings over a period of time during a day, and obviously at the end of the year savings can be considerable. Equally, where there are two or more pieces of equipment working in parallel and which are they partially loaded, it might be possible to turn one of them off and maximize the performance of the others, so you will drive your energy just on a device, increasing its efficiency. If you look at the figure, the picture, illustrate just the intersection of this, an example of a pump, the characteristic curve of a pump that with a system performance curve at different flow rates. So you can see that going from point 2 to 0.91, you can just increase your efficiency, just changing some settings of your system. So this is depending on, as an example, on a pump versus the total head and the flow rate of the pump. So just changing some setting, as I said, you can achieve considerable savings. Obviously, if you need to install and to purchase a new motor, a brand new motor, you will need to optimize your design in order to maximize the efficiency and the operating points of your motor. Example of this again are on the like ventilation systems, HVAC systems. That it's really important to design even the ducting to to choose the right motor and the right wattage of the motor. Other opportunities for energy savings are on the variable speed drives. As I mentioned before, a variable speed drive can be purchased and installed, can be fitted to an existing motor, or you can buy a new motor really that is already fitted with a variable speed drive. The function of a variable speed drive just is about adjusting the speed of the motor to the process demand by equipping it again with an inverter. Application of this can be found within a wide range of technologies, from fans to pumps, compressors, conveyors, mills, mixers, and many others. Obviously, an additional benefit of installing an inverter is also the better control of your process, and you can even monitor more accurately your process. Another device that can be installed and fitted to a motor, it's a soft starter. So a soft starter really, as obviously a motor draws high current from the supply during the starting. To reduce this starting current, it is possible to fit a soft starter device that limits the current to the motor during the startup. Obviously, benefits are not only on energy savings, but obviously this will extend the lifetime of your motor, because obviously you will avoid much overheating. The last area that we need to look at for energy savings is obviously the motor efficiency. The motor efficiency, it's something that comes together with your motor, and as we're going to see in a few minutes, this could be quite crucial when you need to decide whether repairing a motor or purchasing a new one. As I mentioned before, we can give some focus on the variable speed drives because they can deliver fairly high energy savings. On the slide, you can see two different pictures that relate to pumps and fans application. So if you fit a variable speed drives to a pump on the left side, the picture just shows how using a variable speed to control the flow rate from a pump rather than using a simple throttle control can result in large power and obviously cost savings. If you see the flow rate, slowing down the flow rate and using a fixed speed input power, so your power decreases, but not as much as if you install a variable speed drive. Obviously, the crucial points of installing inverters is that savings follow, and obviously power that you absorb, the motor absorbs from the grid, follows a cubic relationship between the speed and the power. So this is just an example. By reducing your speed by 20%, you can reduce your power by nearly 50%, so, and energy as a consequence. Obviously, if you need to run your motor at 100%, you don't need really to install a variable speed drives, because if you see on the picture, if you're running your pump at 100% of the load, there's even more consumption on your motor, because obviously this is due to losses within the variable speed drive and obviously the motor. But obviously, if you can slow down your flow rate, it's extremely convenient to fit the motor with variable speed drive. Now, if we move to the fan application on the right-hand side, you can the trend of energy savings that can be achieved within fans. It's very similar. So you can see, if you have just a fan that is controlled by a damper, the input power reduces as the flow rate decreases, as we said before. But obviously, under a variable speed control, the power reduction is more dramatic, as you can see from the picture. So those two technologies, fans and pump, follow the same trend regarding energy savings that can be achieved from a variable speed drive. This is the best way probably to explain how variable speed drives are so important to gather energy and cost savings. So if we look at this is a case study we worked on a few months ago. So there was a motor, 22 kilowatt motor, that was running at 15.1 kilowatts. So that was partially loaded, was around 75%. Was running for 6,000 hours per year, and considering the tariff 9p per kilowatt hours, that motor had a running cost of £8,000, more than £8,000 a year. Obviously, after the technical assessments, we've seen that it was possible to reduce the flow demand of the pump by 25%, and for nearly 60% of the time. So we can say that the speed obviously can be maintained for the remaining 40% of the time, so 1,450 RPM versus 1,087 RPM for the rest of the time, that is 60% of the time. Obviously, the power goes from 15.1 to 6.37. This can be calculated just applying the affinity laws of the pump, but I'm not going to in depth to explain that. This can be really understood. So we just need to consider 15.1 versus 6.37. So if we calculate how much energy can be saved from this upgrade, we can see that there are 2,800 more than that annual savings on that due to the installation of a variable speed drive. You can see even from the picture the power reduction versus the speed of the motor reduction. So the investment for this project was £4,000. So if we consider the 30% capital contribution given by the Green Business Fund, we'll run through all the details of the Green Business Fund afterwards. But we can see that in this case, the payback, the net payback of the investment has been really good. So we're just talking about 1 year payback. We have many other case studies that can indicate how convenient it can be to install variable speed drives to existing equipment, or purchasing new equipment like compressed air that comes with variable speed technology. In this case, on the compressed air side, this company just replaced a 22 kilowatt fixed speed compressor with a 30 kilowatt variable speed machine that costed 10.4K, and the savings from controlling the compressed air use and the pressure were more than £4,000, and the payback in this case is just talking about 2.5 years. And obviously in this one, if we add the benefits from the Green Business Fund grant, the payback can be even better on that. Another case study is on the funds technology. So this company was a glass manufacturing company that equipped to 200 kilowatts motor fans with an inverter, and this project costed 43.5K, but the savings coming from this implementation were absolutely outstanding. So we're talking about 35.6K per year. So the payback really is 1.2 years. This is a very good payback, and we can see that when and where there are the right condition to install an inverter, paybacks are really good. Obviously, as I was saying before, not always is possible and not always is convenient to install inverters. Just as it is, you will need to assess your motor, and maybe this should be done by a specialist, by a consultant, or by a supplier can monitor the motor, can assess the process, and eventually can provide you with an option to correctly size the motor and or install inverters to your equipment. Now we have seen all the benefits from the variable speed drives. So what I would like to talk to you about is the motor efficiency. Motor efficiency is something that you need to consider when you are assessing a motor. The motor efficiency is something that has been introduced in 2008 by the International Electrotechnical Commission, IEC, by their standard, and that gives the users a simple indication of the efficiency of a motor. Currently, if you can see from the pictures in the middle, the IEC efficiency classes are 3, so going from the best efficiency, that is the IE3, to the IE1, that is the lowest. There's another classifications of efficiency, that is the European CEMP-EP, that is classified using just EFF 1, 2, and 3, but usually the IEC is the one that you need to look at to classify and to assess your motors. Obviously, there are regulations that set efficiency requirements. You can see from the picture on the left side that, for example, from 1st of January this year, 2017, all the motors with a rated output from 0.75 kilowatt to 375 kilowatts must meet either the IE3 efficiency level or the IE2 level and be equipped with a variable speed drive. So if you need to purchase new equipment, you just need to take that into consideration. Just in terms of efficiency itself and savings that can be achieved by using a more efficient motor, you can see that obviously high efficiency motor can cost more, they're more expensive than others, but obviously in a long-term perspective you can save from 2 to 5%, obviously depending on the size of the motor. You can see on the picture on the right, that's a picture, an efficiency class band for 4-pole AC induction motors. So you can see that the lower is the output of the motor, the more efficient are the high efficiency motor, like for example the IE3. Just to give you an idea of some figures about the high efficiency motors, an 11 kilowatt high efficiency motor that is continuously used throughout the year will use almost 250 pounds less energy than an high E1 motor. So we'll go through more figures on a case study. This is a case study that it's about replacing an E1 motor with the best efficient motor, E3 motor. We're talking about 37 kilowatt motor that is fairly typical on extraction system or presses, so manufacturing site probably. This motor we're running at 85% loaded, so 31.45, fairly high running hours per annum, so more than 6,000. And the existing motor had an 88% efficiency on that. The client just calculated and monitored the running cost of that motor that was nearly £20,000 per annum. After upgrading this motor to a high efficiency motor that comes with a 93.6% efficiency, so that's nearly 6% gap between the two motors. We can see that the annual cost savings are around 1,100. So if we invest, as in this case, £3,000 to purchase a new motor, and if we consider again the capital contribution that can be given by the Green Business Fund, the payback again in this case is extremely good, is less than 2 years. So it's something to consider when assessing your motor efficiency and see if you can upgrade your motor to a more efficient one. One thing that I would like to focus on is also not only the efficiency itself of the motor. When you are doing an evaluation on whether replacing or repairing the motor, like in this case, you could have repaired your motor, E1 motor, and that could cost £800, so fairly cheap to repair. Versus £3,000 of the new motor. So if you just look at the investment, obviously you might go for the cheapest one. But if you project the running costs of your motor over a 10-year lifetime, you can see that your running costs of your E1 motor that could have been repaired is about £197,000 versus £188,000. So in 10 years' time, there's nearly more than £9,000 savings. So your investment should be always assessed, especially on electric motors, on the projection of the whole lifetime of your motor, of your device. Right. So just to conclude this section on the motors, we are going to see. I'm going to give you some tips on how to set up a motor management policy. That is very important to have, because obviously a motor management policy will provide a structured approach to the repair and maintenance of the motors. And your organization will benefit of it just because if you set your policy on motors, you should schedule all the procedures for motor maintenance. You should set up a plan for purchasing new, more efficient motors, and obviously you should plan even the repair of failed motors, which always should including, as I said before, a comparison between repair costs and purchasing new motors using the whole life cost of it. And obviously you should create a method for tracking the number of times your motors have been rewound. Obviously, to create and to manage a good motor management policy, you will need a commitment from senior management. You will need sufficient resources for both the planning and the implementation sides, and obviously you should set clearly, as you should define responsibilities within your organization, so who does what, and always review the changes in prices of the motors themselves, or the cost of the electricity, or new products on the market. It's very important, as I said, so that all levels in the company should be given the relevant authority to influence equipment purchase, and also the policy can demonstrate the company commitment to energy efficiency to stakeholders. So this is not only a benefit for the motors themselves, but also for the company on an environmental side. As a rule of thumb, when the size of the motor is large, you should assess and should carefully evaluate whether to rewind or replace the motor. Usually, when the motor size is below 5.5 kilowatt, the motor should always be replaced. But obviously, there could be some cases that could be worth just repairing it. So it depends on the application, on the running hours per annum. So just the chart gives you just a very general indication of how you should assess your motor replacement or repair. Obviously, high annual running hours can lead to replace the motor, especially, as I said before, when the size of the motor is fairly low. Obviously, if the operating hours per annum are not that high and the size of the motor is quite large, so it could be worth rewinding the motor. That could be convenient, even if you consider the life cost of the motor over 10-year time. Obviously, a motor should not be rewound more than twice unless there are exceptional circumstances. So, as I said before, there could be any other things that influence the choice. Just to conclude, really, the technical section on the electric motors, on the slide you can see some other energy savings tips that can lead to achieve some benefits, some savings. They really are, first one is about loading the motor. The modern motors usually operate most efficiently above 50%, with a peak between 75 and 90% load. So before purchasing the motor and choosing the size, you should really know what's the load of that motor for the next years for the right application. Sometimes it could be worth fitting the motor with power factor controllers. Power factor really reduce the average voltage supplied to the motor, resulting in an energy reduction of due to reduction of iron losses. Savings are in the region of 1 to 3%. As I said, to install power factor controllers, it's really important that the motor has been assessed by a specialist or by a consultant. When we have belt-driven pulley, usually we can save some energy by using wedge or cogged wedge belts that can maintain the efficiency around 2% higher than the standard V-belts. So this could be another thing to look at. And the last one is the gear control. So new helical gearbox come with an efficiency of 98.5%, and that can be more efficient than the warm gearbox that obviously can deliver a very high torque, but the efficiency is around 85 to 90%. So we have seen from a technical perspective how to save some energy, and hopefully gave you an overview of the motors technology. Now I would like to introduce the Green Business Fund and what the Green Business Fund is and why it could be important to optimize and to achieve savings at your organization. The Green Business Fund, it's a scheme operated by us, by the Carbon Trust, to improve the sustainability and energy efficiency of organization. So currently the scheme serves small and medium companies in England, Scotland and Wales. It's been running since 2016, and it's due to run until the end of the year. Funding are still available, so as you can see afterwards, we could be a good scheme for you to achieve and to implement energy savings. The fund today provides a combination of advice, training and direct contribution for capital equipment, and there's scope for the fund to expand both in the UK and international if such additional funding can be made available by a suitable body. As I said before, the scheme covers England, Scotland and Wales. Eligible for the Green Business Fund services are all small and medium-sized businesses, schools, sole traders and charities. Unfortunately, the fund doesn't cover domestic properties, the public sector and new buildings. How we define small and medium businesses, there are two of the following criteria on the right side that need to be met. So the business shouldn't have more than 250 employees, the turnover should not exceed £25.9 million, and the annual balance sheet should not be in excess of 12.9 million, and no more than 25% owned by an entity which doesn't meet the criteria. As I said, the Green Business Fund provides 4 types of support. So regarding the training support, we deliver a 2-hour workshop around the country. So the workshop is hosted by a Carbon Trust partner and is delivered by the Carbon Trust. The scope of the workshop is to understand the energy consumption and identify no-cost or low-cost measure. This is for companies with less than 50 employees, and so far we've trained over 135 companies. So there are actually 2 coming workshops. One is this week in Devon, 2nd of March, and another one in Southampton, the 14th of March 2017. So you might be interested in attending the workshop. We provide within the scheme even opportunity assessment, so really energy audit. So the audit can be done by remote, or it can be an on-site assessment. The audit is delivered by a chartered engineer, the Carbon Trust. Once we have audited the company, we provide the business with top 3 costed and energy savings recommendation. So we always provide savings versus cost of the investment that need to be afforded by the business. And obviously this sort of support is available for small and medium companies, as I said before, in qualifying geographies. A recent case study that we have delivered is at the APS Metal Pressing. This is a company in West Midlands. They can reduce the energy bill by 12k per year, and the payback of the coming from the 3 recommendation is just 2.7 years. Sometimes it's quite straightforward to identify energy savings. We provide also within the scheme an implementation advice support, up to 5 days support for the business, and again, this service is delivered by Carbon Trust consultants to assist the implementation. This support is for companies that have done their case study, their business case and they are ready for the investment. So what we do is we invite selected suppliers to provide proposals and quotes for the company. We assess the proposals and we come back to the clients with our comments. So basically we do technical procurements and due diligence on that. This support is aimed for non-large companies up to 1,000 employees, and as I said, is for situated in qualifying geographies. This is another case study that we recently implemented. It's just upgrading the existing lighting system to LEDs. So the cost of the investment was £8,000. This was sport hall site, and the payback was really good. So 2.2 years. Obviously, the Green Business Fund provides even capital contribution. So we provide 30% of capital contribution for projects with a payback that is less than 5 years. If the payback of the investment is longer than 5 years, we can provide some funds, but the bonus, the grant, is calculated based on 5 times annual savings by 30%. It's a straightforward process as we operate the scheme with our accredited suppliers. So we just we technically assess the projects, and we make sure that the implementation meets the best practice criteria and meet high standard for the sort of technologies that the company is aiming to implement. So technologies that can be founded are, as you know, from the electrical motors to HVAC to lighting, compressed air, and many others. So really everything that saves energy can be funded. Another scheme that we run at the Carbon Trust is the interest-free energy efficiency loan. This scheme is designed to support businesses in order to upgrade to more energy efficient equipment, and obviously renewables are part of the scheme. The scheme, those interest-free loans are available in Wales and Northern Ireland. Technologies that can be parts of the scheme are building technologies, so heating, cooling, building insulation, heat recovery, lighting, piping, insulation, and solar thermal systems. Even industrial process technologies can benefit from the scheme, so compressed air, motors, process heating, process controls, refrigeration, and variable speed drives, and also renewables, so from the typical and most common renewables, solar PV, solar thermal, but also wind turbines, hydroelectricity, and biogas and biomass applications. The companies in Wales can borrow from £3,000 to £200,000, and in Northern Ireland from £3,000 to £400,000. The loan offer is based on CO2 savings, and so we offer £1,000 for every 1.5 tons of CO2 that is saved annually. The loans are designed so that in most of the cases the repayment, the monthly repayment, is similar to the reduction in the customer bill, so really the customer doesn't spend any money to implement energy savings. Those savings are checked by our engineers to provide sense checked, and those loans are interest-free, they are unsecured, and they have no setup fees. In Wales, this scheme, the interest-free loan, can be used together with the Green Business Fund capital contribution that funds up to £10,000. So companies in Wales can benefit from both the schemes. If you have any questions, please do send us an email at loans@carbontrust.com or give us a call on the number shown on the slide. Now we are going to run through the ETL, and my colleague is just running through the scheme and what ETL is.
Hello, I'm Kay Rolton. I'm from the Energy Technology List. So Alessandro has talked a lot about energy efficient equipment, motors and drives. And so this slide is to draw your attention, if you're not already aware, of the Energy Technology List, a government-approved list of energy-efficient products, and we do have a lot of energy-efficient motors and drives on that, and so you might want to take a look at the link there. And so these typically are the top performing energy-efficient products, so we aim to attract the top 25% of energy-efficient products on the marketplace. And also to make you aware that organisations that pay income or corporation tax can claim enhanced capital allowances on the purchase of that equipment. So that means they put the cost of the equipment and any direct installation or transportation costs against their taxable profits, so they end up paying less tax. So an example here is if they were spending £10,000 on equipment listed on the Energy Technology List, the benefit to them, with corporation tax being currently the standard rate 20%, then the benefit to them could be £2,000. So a little bit more information is available on the Carbon Trust website about that through the couple of toolkits and flyers that we show there. Or if you do have any questions, please email ecaquestions@carbontrust.co.uk. Thank you.
Thank you. Just to conclude this webinar, I'm just running through now our Green Business Directory. So if you're looking to install as an organization an energy efficient or renewable technology, as you might have experienced already, there are a number of barriers that can be from knowing which supplier can be trusted, or differentiating between suppliers in the market. There are quite a lot. And then a lack of customer understanding if you haven't got the right resources within your organization. And obviously the time to be spent to assess and to implement a project. So we have developed the Green Business Directory, where you can find, is actually a market-leading supplier directory, where you can find, depending on the technology you are looking at, you can find the right supplier for you. So in order to carry out a high standard implementation. So please go to the website if you need this sort of support, and then you can easily find and filter by technology, by area, and you will see which suppliers can be the right match for you. Obviously, within the Green Business Fund, we use Green Business Directory accredited suppliers, so benefits from using the accredited suppliers are there because we've worked with them and they have got the accreditation, and you know that they will provide a high standard solution for you. So I think we've nearly done. We are going to be answering now any questions that you've submitted or you might have. Okay, we've got a question from Sarah. Hi, how have you calculated absorbed power of motor, the load percentage? Yes, I think you're referring to the case study with the installation of an inverter to a pump system. So basically, the absorbed power has been calculated from the affinity law of a pump. So if you have a pump and you know your flow rate, from the flow rate you can calculate your power through the knowing the specs of the pump. So really you can calculate the ratio between the speed, the flow, and knowing the characteristic curve of a pump, you can get the wattage of that. But I can send you more details. Just if you send us an email, I'll send you more details about the calculations of the pump. I haven't included all the calculations, but yeah, I can send you a breakdown to achieve the absorbed power of that motor. There's if you go to the website, you can send us, and if you have any questions about the Green Business Fund, you can find quite a lot of information on the website. But if you have any other questions, you can send us an email at greenbusiness@carbontrust.com. So on behalf of the Carbon Trust, thank you for joining us today, and enjoying the rest of the day. Thank you.